to the microphone.
Hi, everybody. I'm Mark, and Ryan, my partner, is over here. We are Kopernikal. Devin is on his way. He'll probably come just after I finish, most likely. What I'm going to talk about tonight is a lumbar interbody fusion device that we've come up with. And for those of you that aren't familiar, all right, I'm just going to do it from the computer. No, that doesn't work either. Okay, sounds good. Thanks, Ruth. All right, well, first of all, what are we talking about? Like, what is the problem that we're trying to solve here? So, lower back pain is something that is highly prevalent. People get back fusions all the time. One of the ways that people get their lumbar interbody fusions is called an ALIF, which is Anterior Lumbar Interbody Fusion. There's several different other types of interbody fusions that can be done. Some are done from behind, some are done from the side. But the sandbox that we're playing in is this particular procedure that's done from the front, anterior. Anterior lumbar interbody fusion is probably the second most common in terms of approach. Most of them are done from behind. However, this particular anterior approach is attractive because you can get the biggest implant in for the greatest stability. And doctors love it because it also pays them more than all of the other procedures do. The device is also reimbursed more nicely than implants from any of the other procedures. But the problem is, if you go from the front, you have to go through the gut, and then before you can get to the disc space that you're trying to fuse, you've got two major vessels that are right in front of that disc space. And so the procedure itself carries a high risk. This procedure, oftentimes a spine surgeon will tag team the case with a vascular surgeon to provide the access. And so even with that, having two surgeons in the room, that risk is still very real because of those two very important vessels that lie right in front of where you're trying to place the implant. So what we have endeavored to do is to create a safer solution for an ALIF. It's still an ALIF implant, but it's done in a way that is lower profile and the procedure itself is more streamlined. All right, so here's the money slide of what it looks like. So these are different cages on the market that are already existing, and the way that they work is the surgeon will put in the cage and then drive 3 or 4 screws through that cage into the adjacent vertebral bodies. And this is kind of hard to appreciate because the resolution's not great on this x-ray, but this is happening basically at your belly button level from the front. Put the implant in, then drive screws through the implant to fixate it and stabilize it. Oftentimes, it can also be additionally stabilized by having plates and screws placed on the front. Now, the problem is you have a very narrow access corridor to visualize the disc space, put in the implant, and drive the screws. You're challenging that corridor constantly if you're trying to put in angled screws. As you can see, these screws are angled. And so imagine if your corridor placement is really just this straight pipe that's in front of the implant, and then if you're trying to drive angled screws, you're really challenging that envelope to put those screws in. So what we endeavored to do is we've come up with a design solution that everything is done straight down that corridor, one single instrument driver that actuates fixation screws that pop up north and south. So perpendicular to the implant, it's that angle of fixation is actually optimal. It's if you have these screws that are coming off at say 45 degrees into the adjacent vertebral bodies, they're not going to be as effective as screws that go straight up and down. All right, so that's our idea. The company Kopernikal is a throwback to the design, which has a planetary gear and satellite screws that go up and down into the vertebral bodies. Next slide. So this is our tagline: safer, stronger, faster. So why is it safer? Because the risk of vascular injury is reduced. We're not challenging that operational corridor as much. The step and workflow are reduced because we have just one instrument and one step of driving those screws home, and then because it's safer, faster, and stronger because of the 90-degree screw orientation, this is going to be better both for patient, surgeon, and hospital. So if you can reduce the number of steps, operation can happen faster. The surgeon's happier, the hospital's happier, and then if you can reduce the number of SKUs, and actually our intent is to make this a single-use, sterile, packed device, procedure, instruments and implant all in one. So there's no reprocessing, there's no inventory of different size screws that you need to keep track of, or even implants. We'll simplify it maybe to a couple different footprint sizes, but the number of SKUs involved in carrying out a procedure is drastically reduced, and so it's really going to benefit company, hospital administration, and surgeon, and ultimately the patient. Next slide. A little bit about the sandbox that we're playing in. It's a massive market for interbody fusion devices. Our slice of the pie, probably the second largest piece of the pie in terms of approaches, the anterior approach. And then in terms of how much we want to capture of that within the first 5 years, this is our forecast is up to 40 million. And that's based on procedure volume times the average sales price for that procedure. Yeah, that's the finance slide. I run out of, okay. This is not a space that we're playing in. Lots of history. This market is mature. Bigs are already in it, like Medtronic. I'm sure everybody's heard of Medtronic. There are some smaller players like VB Spine and Carlsmed that are also trying to play in that space. But what is really sexy at the moment is 3D printed titanium implants. That's what ours will be. However, ours will be better because everything will be able to be printed all together in the assembly. The screws are actually not separate components from the implant body. They're actually integrated into the design. So one 3D print, processing, and then one instrument to drive the whole thing. Next slide. All right, so here's where we are right now. We literally just filed our patent for this, and that was a fantastic achievement for the team. We've prototyped this, so we have some working prototypes, albeit in plastic, but the next step is to take that to metal, and we actually have a really nice community here in San Diego where spine and supporting companies that support spine manufacturing live. And so we're tapping that, and the next step will be to do this in metal. We've actually shown the idea, talked to a number of vascular and spine surgeons already, and have confirmed that, hey, we're not off target. Later this year, we want to do a cadaveric evaluation where we actually implant it into either an animal model or a cadaveric model and just make sure that it actually works. And concurrently, alongside of that, we're going to just check in with the FDA, make sure our regulatory path that we've anticipated is as clear and defined as we have anticipated that it is, but we're going to do a gut check on that this year and then take it to market probably a year later. That's an aggressive schedule, but we've got a good team. Next slide. That's what I essentially just walked through. All right. You can go back one slide. Okay, so the core team is the three of us, Devin, myself, Ryan, and then we have a supporting cast behind us for IP counsel, marketing, and regulatory. But we're pretty small right now. And here's our ask. So we are trying to raise $3 million to get us through 510K clearance. And that, in the world of medical devices, is a great milestone where we can be attractive for acquisition and or taking it ourselves further.
Yeah, just for my personal understanding, is the implant like fusing your vertebrae together? So if the disc is messed up, it like replaces it? Is that the idea?
Yeah, so in a lumbar interbody, you are stabilizing it and holding it still. There.
Okay, and then another, just out of curiosity, is your model also, does it go through the stomach or the gut?
Yes, it's an ALIF implant, so it does the same ALIF procedure, anterior approach. Yes.
Okay, and then why is that? Wouldn't it be easier to get to this, like to the back?
Right. Yeah. Most spine fusions actually do happen from a posterior approach. However, there's probably a third that had happened through anterior through lateral approaches, and each approach has its own benefits and risks. But the ALIF is still a pretty significant portion of those that's attractive for surgeons and companies.
Yeah, thank you.
Yeah, great question.
In the orthopedic space, and by the way, congratulations, this is very impressive work, so congrats to your progress and your patent submission. I was just curious, with the printing technique, are there many other orthopedic implants right now done that way? Were they able to get approved as a 510K versus de novo?
Yeah, excellent on the regulatory path, because of course we want to show that we have a clear runway from a regulatory perspective. And yes, there's several predicates that have already paved the way for us in terms of 3D 510K. This has been well established in terms of procedure and implant design for us by many other companies, and most importantly lately 510K procedure. So we are following that same path. There is some novelty to ours, of course, that will probably raise some questions, and that's why we're going to do a Q-Sub meeting first to just say, hey, this is what it looks like. This is the form, but we just want to make sure we're not missing anything as we really chase that down.
Any online questions? Any more questions in the room?
I guess I could just think of one or two others.
Yeah.
Is the looking forward single level versus more, more than one level? Do you have an inclination of this technique being more valuable for single level or not? And my understanding is once you put in any of these, you tend to have a progression, a loss of bone in the surrounding bones. Do you foresee, and I understand you haven't done the preclinical or the cadaveric, I guess won't demonstrate that, but in maybe another model, would it have some advantage for protecting the quality of the surrounding bone longer?
Yeah, so to answer the first part of the question, whether a patient gets a single level or a multi-level fusion, that really depends on how bad they are coming in.
How good their insurance company is too, so side note.
Yeah, I mean, I hope that's not the case, what's driving the procedure, but it could be that they're to that one, but it could be that they surgeon. In regards to, and this will be something that has indications for multi-level, not just a single level fusion. But if it's used at one or two, that's the surgeon's decision. In any case, to answer your question about does it have any adjacent level effects and benefits? So the screws on ours are actually slightly smaller, and we can go smaller than what's out there right now because our angle of fixation is actually orthogonal to the implant. It's 90 degrees to the implant. And so the same fixation that an angled screw that's larger gets in the bone, we're able to achieve with a smaller screw because we're going straight up and down. And so because of that, we're not occupying so much of adjacent vertebral volume with a screw as predicates. So less disruptive in that regard. Great question. Thank you.
Any other questions? Okay.
Thank you very much.